In this video, the third technical video in this series, we'll take a look at the editors and the form view controls and see how they are used within the project punch list component. The form view control provides the capability to create editable forms that can use a specific editor for editing the value in the form. On a mobile device, you typically use a different editor for the different field types. For example, a spin list may be used for a date, a text box may be used for a line of text like a name, and a text area would be used for a multi-line text like a note. Form views can be used like a detail view in a list control. In the Project Punch List app, the form views are contained within panel cards that are included within a panel layout that also includes a panel card for all the editors. The editors are revealed from the top of the panel card, which ensures that the keyboard will not interfere with the form. The editors are displayed in a docked panel that is displayed when the form view field is tapped. You can cycle through all the form view fields programmatically, and the appropriate editor is displayed for each field. Let's take a look at this functionality. I'll select a project and open up one of the punch lists and swipe the row and then tap on the edit button to bring up the form view that is associated with this list. Next, I'll tap on category to bring up the editor for the category field. The editor appears and a selection list appears. If I click on the arrow key in the control bar, the editor for the next field is displayed. This will cycle through all of the fields of this form. If I click on the text in the editor in the description field, let's say, a keyboard is displayed to allow me to modify the text. If I tap on the next field button, the keyboard will disappear and the next editor appears. If I make a change to any of the fields, the green checkbox will dismiss the keyboard and commit the changes. The red circular left arrow will dismiss the keyboard and cancel all edits. These buttons are contained within a single control bar, and all the forms are updated as required. Both buttons will also hide the dock that contains the control bar. Let's take a look at how this behavior was implemented. First, let's look at the structure. A panel layout is used for the editor control and form navigation. In the panel layout properties, I've indicated that the flow is top to bottom. Docked panel display option is set to push, and the dock lock flow property is checked. That means that when the panel card that contains the editors and the editor control bar is displayed, the other panels are locked and the user cannot interact with them. I'm also using a slide animation when the dock panel comes into view. The panel card that contains the editors and the control bar that handles the form view field navigation and the commit and cancel buttons is set to 300 pixels in size, and the dock is set to collapse before so that it will not be shown when the panel cards that contain the numerous form view controls are brought into view. We only want the dock panel to show when any of the form views is using one of the editors. Each field will be mapped to the appropriate editor in the different form view controls, so only one editor will be shown at a time. Next, I'll expand the editor set. Here you can see I've got 4 editors defined to handle all the different field types. Editor 1 is a text box, editor 2 is a spin list for dates, editor 3 is a list box with some static placeholder data assigned. The list will be dynamically populated at runtime with data from the client-side data cache. The client-side data cache is populated by a callback to the server-side MySQL database when the app is first fired up, assuming that the device is online and that the server is available. Editor 3 is used for the punch list item category and punch list item status selections. We'll take a look at the logic a little bit later. Editor 4 is for the punch list detail notes, and that is set up as a text area with a height of 150 pixels. Next, let's take a look at the form view controls that will use the editors. All of the form view controls are contained in panel cards that are included in another panel navigator. Since these form views act very much like a detail view, each one is called programmatically when the user taps on the edit button that is revealed when a right to left row swipe is initiated. The click event on the edit button will display the respective panel card that contains the associated form view. Each panel card that includes a form view also contains a control bar that is used for navigation. Let's look at the properties of form view underbar 1. The data source is list underbar projects, and each field is assigned to a specific editor. All of the editors in this component come from the same editor set. If we look at the form layout, you can see that I'm displaying the project photo at the top of the form, and then including a tab control that displays project details, owner details, and a map. At the top, you can see that the image data bound control is used, and if we look at its properties, you'll see that I'm allowing image capture and using a button to bring up the device's camera. The layout of the button is defined in the template, and you'll notice that I'm centering the button. The project details and the owner details tabs are using a layout container to display the city, state, and zip fields on one line that will be automatically adjusted to the device's width. The width type of this layout container is set to explicit, and the columns widths are set to 80% for the city, 10% for the state, and zip. Notice that column breaks are used to identify each column. In one of the tabs, I'm displaying a map that is using the project lat long fields to display a marker and center the map. The lat long fields are extracted from the EXIF data when a picture is taken. I wanted to allow the user to tap on the static map and bring up a dynamic Google map that would allow the user to zoom in and out and to toggle between the different map views. I did that with a Show Map item defined in the Items tab. The template references an A5-item attribute and sets that equal to Show Map. Template items are an efficient way of adding an event handler to the template HTML markup. Rather than each row in the list having its own custom event handler, this technique lets you define one custom event handler that is called when required. If I open the Items tab and look at the onClick event, you'll see the JavaScript that sets the map properties and displays the panel card that contains the map. Let's look at the form properties, specifically the initial state settings. Here you'll see the initial state is with tab 1 active. The problem is that once you've activated another tab and navigate away from the form view, the next time you bring up this form view, the active tab will be the last tab that was active. This is not the behavior I wanted, so I handled that by setting the active tab each time this panel card is displayed. The form views are displayed when the user swipes a row from right to left to reveal the edit and delete buttons. In the original component I wrote, the JavaScript and the CSS to make this happen. As of build number 4554, you can now define this functionality in the list builder properties, which is much simpler. I'll open the list properties tab for the projects list, and you'll notice that the has custom row side to side behavior is checked. If I open the list row drag action builder and look at the defined actions, you'll see the JavaScript for the edit button. Here I am storing the selected row data to the data variable and using the list set value method to the underbar primary key value. This will load the row data into the associated form view. Next, the highlighted block of code is used to set the active tab to tab number 1, and then the form is brought into view. This same pattern is used for all the child lists. Let's review what this all looks like in the app. I'll swipe from right to left on a row and the edit and delete buttons appear. When I tap on the edit button, the form view appears and the active tab is set to tab 1. I'll select tab 2 to display the owner details. Next, I'll navigate back to the parent list by tapping on the left arrow in the control bar and edit another project. You'll notice that tab 1 is always the active tab when the form is first displayed. With the form view displayed, I'll tap on a field to initiate an edit. When I do that, the editor slides down from the top of the form, displaying another control bar that allows me to navigate through and edit all of the fields displayed by this form. Also notice that the left navigation arrow is disabled in the form control bar. All input is focused on the displayed editor, and the editor will never be blocked by the displayed keyboard. If you tap outside of the editor or tap on the Save or Cancel buttons in the editor control bar, the keyboard is closed. The editor is animated out of view, and the Form View Control Bar Navigation button is enabled. The Form View Control Bar button states are controlled by two events fired by the panel layout control. They are the on-dock panel show and the on-dock panel hide events. If we take a look at the on-dock panel show event, you'll notice that I'm checking to see if an audio is playing, and if it is, it's put on pause. Next, I'm defining an array of the names of all the control bars used in the numerous panel cards that contain the form views, and calling the disable back button JavaScript function, passing in the control bar object as an argument. I'm enabling the buttons with a similar function called enable back button that is called when the on-dock panel hide events fire. Let's take a look at those two functions. I'll open the JavaScript functions, and here we can see the disable back button and enable back button functions. All I'm doing here is setting a control bar variable called editorActive to true or false. Let's take a look at one of the control bars to see how the control bar's editorActive variable is used to control the enable and disable state of the back button. I'll select control bar under bar 7 and click on the Data tab. Here you can see that a control bar variable has been defined called editorActive, and that it is set to the JavaScript value false. This is the value that is being changed by the enable and disable back button functions in each of the respective control bars. We have a total of 3 control bars that are affected each time the dock is displayed and hidden. If I click on the Items tab, you'll see that the disabled expression for the back button in the control bar is set to editorActive. You'll see the same setting in all of the control bars used in conjunction with the form view controls. You'll notice that I didn't worry about identifying which panel card or form view was active when I set the state of the navigation button in the control bar. I just set them all, and that's because it was easier, and it really doesn't matter in this case. Let's take a look at another form view that uses multiple editors. This is the form view for editing and adding the punch list items. It includes a list for selecting the punch list item category, like door hardware, countertops, interior paint, etc. And it also includes a list for the punch list item status, like completed or in process. This is implemented using the same editor, and the data for these lists is based on a SQL query, and the return data is stored in a client-side data cache for offline use. A problem arose with this strategy if the device was offline the first time the app was initiated, because the app could not make a callback to get the data for the client-side data cache. To resolve this situation, I had to provide some default data that is updated when the app is online. Let's take a look at how that was accomplished. I'll click on UX Properties and then Client-Side Data Cache. Here we can see 2 data cache items, categories and status. They are both based on SQL queries, and the results are persisted to the file system. I'll edit categories, and you'll notice I've checked Delay Query until Explicit Refresh or Read. Also, Store Data on the device is checked, and the file system preferred is defined as the storage location. What all of this means is that when the app is first launched, it must get the data, so if the device is offline or the server is not available, it can't get the data to store on the device. The solution to this problem is to detect when the server is not available and provide some default data so that the app is useful. I've defined the default data in the client-side onInitializeBegin event. Here you can see that I've created an array of default categories and an array of default status, and made them properties of a global object called thisApp. Next, let's take a look at the setValue and editor property for editor under bar 3, which is the editor used for these fields as specified in the form view. I'll show you how that is assigned on the form view in a minute. I'll scroll down to the underbar onServerNotAvailable function, and you can see that I first define an object called underbar data. Then I'm setting a default status variable and a default categories variable with the contents of the respective arrays from the thisApp object. Then I'm using the JavaScript ternary operator to assign the proper value, either default status or default categories, to underbar data by looking at the item property. Finally, I'm calling the underbar onSuccess method of this editor and passing in the data. Now the editor list will always have some valid data. Once the device is online and the server is available, The SQL queries will be executed and the client-side data cache will be populated. You may never need to use the default data, but it's a good idea to think about this type of scenario when you're building a disconnected app. Next, I'll open the form view that uses this editor. In this case, that is Form View Underbar 2. From the Fields tab, I'll select Category, and you can see the editor is set to Editor Underbar 3. I'll open the Editor Configuration Genie, and here you can see that the list data source is a client-side data cache, and that the client-side data cache item is categories. You'll see something similar if you select the status field, except this time the client-side data cache item is status. That wraps up this discussion of the editors and form view controls used in the Project Punch List app. As with all software projects, there are a lot of different approaches that can be used when coding the app, and I hope you've picked up a few new ideas on how to use editors and form views in your own Alpha Anywhere apps. Thanks for watching.